Welcome to Electrical Lab and Theory. Today's topic is load characteristics of DC Shunt Generator. Make you understand about the DC Shunt Generator. First, we will go through the load theory of behind the load characteristics or theory behind the DC Shunt Generator, and then I will move forward to the connection diagram. I will make you understand the total connection diagram, and then we will move forward to the VLab. You can see here in my PDF. So I am not going through this. I will directly go through the theory. Okay. So we all know that the DC generators are those generators which generate DC current. Means the generator will have some mechanical input and it will convert that mechanical input into an electrical output, and that electricity will be DC, means direct current, right? So what differs the DC generator from AC generator is the commutator. So the commutator makes DC generator different from AC generator, means the commutator changes the AC voltage into DC voltage. Okay, so there are mainly two types of generator, DC generator. One is self-excited, means the field of that generator is energized by its own current or the current generated, and separately excited means the field is externally supplied. Okay, so this is the basic difference between self-excited and separately excited. Self-excited generators are three types: shunt generator, series wound generator, and compound generator. And again, the compound wound generator are two types: long shunt and short shunt. So we will more deeply discuss about the shunt generator because this is the load characteristics of shunt generator. So we'll broadly discuss about the shunt generator. Okay. So let us come to the shunt generator. So this is the connection diagram of shunt wound generator. So what happens in shunt wound generator? A shunt wound generator have a series field, shunt field, which is connected in parallel to the armature, and so that when the armature produces electricity, the current from the armature IA gets divided into two parts. One goes to the field connection, and the other one, the maximum part, goes to the load. Okay, the shunt field has thin wires with more number of turns, so that the current through the shunt field is very less, so the maximum current flows through the load. Okay, so this is the diagram of shunt wound generator. So now let us come to internal characteristics. What is internal characteristic? Internal characteristics is nothing but the relation between voltage and the load current. Generated voltage and the load current. Relation between generated voltage and the load current is the internal characteristics of any machine. Any generator is the internal it is the internal characteristics. So for this DC generator, what happens in internal characteristics? The generated voltage decreases due to armature reaction. Okay, so after some time you will find that the generated voltage will go on dropping. Okay, so this drop is due to the armature reaction. Here you can see the armature reaction here. So for armature reaction, it is slightly drooping, not too much drooping, it is slightly drooping. Okay, so now for external load characteristics is it is the variation of terminal voltage to the load current. Terminal voltage means here across this load is our terminal voltage, is V. Okay, across the armature or across the shunt field is our internal, or what is generated voltage is our internal characteristics, and as the load is an external part of the machine, So the voltage across the load is our external characteristics. Okay. So this is the formula by which we will be calculating our V and Vg. Okay. External characteristics drops so sharply. So it has a drop because of ohmic drop. Ohmic drop means the I square R drop, which when flow R drop, right? So that drop is incorporated here. And for this drop, the external characteristics are more drooping than the internal characteristics. Okay. So that the same thing is written here. So now come to the connection diagram. So this I have made these two pictures, right? So here you can see this is the MCB. So this is our basically the MCB. From MCB we have connected the voltmeter across the MCB, and the ammeter is connected through MCB and the load of the starter. So this is the starter. Okay, this is the starter, you can see here. So I have taken the same symbols. Try to take the same symbols so that you will not get confused. So this is the L. So we have connected one ammeter terminal to L and one ammeter terminal to the MCB, and then after what, it is connected to motor, right? The field winding, you can see here F portion. The F portion is connected to the Z1, so it is connected to Z1, and then the A portion or armature portion is connected to A1. It is also connected to A1, and this Z1 and A1, in between that it is having the field winding, and then Z2 and A2 are short circuited here. You can see here the same thing is written there. So from A2 to MCB, from A2 to MCB, one connection is going, right? From generator side, the A1, Z1 is short circuited here in this point and is connected to ammeter. So you can see here A1 and Z1 is short circuited and connected to the ammeter. Then the ammeter negative terminal is connected to voltmeter, then ammeter connected to voltmeter, and this total portion is connected to L1. So this is the L1. You can see here. And then A2 and Z2 are also short circuited to make it parallel combination, right? So make it parallel combination, the A2 and Z2 are also short circuited, and this Z2 is connected to L2. This Z2 or A2 is connected to L2, right? And from this Z2 it is connected to V, so that the voltmeter reads the voltage across the generator, right? And the ammeter reads the load current. Okay, so I think the connection diagram is clear to you all. So I have given you the steps for the whole thing that I have explained to you. You can take a screenshot, you can copy from here. Okay, so now time for observation table. So I think I have already explained you the instructions or how to connect. I am connecting all those things. So just do the connection diagram and I will come back to you. Okay.
Here you can see I have done the connection and it is showing the correct connection here. If it is not showing correct connection, then MCB will not glow and the DC generator will not start. Okay, so after clicking on the OK button, you can see the generator has started and the MCB has started. Here in lab experiment, you should take the no load without giving any load, but here it cannot be done because without in a single bulb glowing, the motor will not, or you cannot add in observation table. If you add, you can see okay, I'm taking 1 point as a load, then click on the add button and then it will add your readings from ammeter and voltmeter, and then I'm taking 4 bulbs. So here I'm taking the 4 bulbs, and then gradually I'm taking more 6 results. Okay, so now it is the graph thing. So the graph will look like this after you plot the graph. Okay, here you can see the same thing, the same observation I have taken here, and also plotted the graph in the result section.
So here is the conclusion part. The conclusion part is from the above experiment, we did the connections and understand the uses of the components. We put the load on the DC Shunt generator and plot the graph to understand. And we also know about the internal and external characteristics, right? So this is the end. So if you have any queries, you can comment on the comment section. And if you like the video, hit the like button. And if you dislike the video, then hit the dislike button. If anything regarding the experiment or anything you want to ask, you can ask. You can email me on the email address given in the description below. And if you feel the videos which I am sharing with you is valuable to you, just share with your friends and family, so they will also come to know about the things. And consider subscribing my channel. And thank you. Bye bye.